All right. So get ready, because today we're diving deep into something you might think you already know.
Oh, this is going to be good.
Protons. But honestly, there's so much more to these little guys than we think, especially in the quantum tech world.
I know, right?
We're looking at Jorgo Schneebert's Protonen, Baustein der Quantentechnologie. Fascinating stuff.
Yeah, it really makes you rethink what you thought you knew, like in high school.
Totally.
We learned about protons as these, simple pieces of matter, but Schneeberт shows just how complex they really are.
Yeah, it's pretty mind-blowing. We all remember the basics positive charge, right?
Right.
Part of the atom's nucleus, but the same mass as a neutron.
Yeah.
But then you dig a little deeper and it's like, whoa, this is a whole different world.
It really is like you're discovering a secret city right there under the surface.
Oh, like that.
You've got these 3 quarks, 2 up quarks, 1 down quark, and they're constantly moving around, held together by these things called gluons. And it's not static. They're constantly exchanging energy. It's like this dynamic system, a crazy dance almost.
Not just a little ball, but like this vibrant energy system.
Exactly.
And that's what makes them so powerful, right?
Yeah,
For quantum technology.
Absolutely, because protons, you see, they have this crazy property.
Oh, here we go.
Called wave-particle duality.
Oh, yeah.
Meaning they can act like both a particle and a wave.
So they're kind of two-faced.
Well, in the everyday world, a proton's wavelength is tiny, but in certain situations, like particle accelerators, those wave-like properties, they become crucial.
So like tiny bullets, but also like ripples?
Yeah.
That's already wild.
And then there's proton spin, which, isn't actually like a spinning ball.
Right.
It's a quantum property, but it responds to magnetic fields.
Interesting.
Like imagine a tiny compass needle pointing up or down.
Okay, so we've got these complex particles that can be a wave or a particle.
Right.
Yeah, and they have spin that can be controlled by magnets.
And that's what makes them so intriguing for quantum tech.
I bet.
Because that up or down spin,
yeah,
it's basically a binary system, like the zeros and ones in our computers.
Oh, so could we use protons to build quantum computers then?
That's the big question.
But why protons? Why not other particles?
Well, protons have some advantages.
Right.
First, their spin can be manipulated using techniques like nuclear magnetic resonance.
NMR.
Yeah, like what we use in medical imaging.
Right.
So we kind of already know how to work with it.
Makes sense.
But more importantly, protons are really stable.
Okay.
They aren't easily disturbed by their environment, which is so important for coherence in a quantum system.
So they're like the calm ones in the quantum world.
Exactly. And this stability means longer coherence times, which is super important for building reliable quantum computers.
Oh, I see.
If you're trying to do a complex calculation, but your calculator keeps changing numbers randomly.
Yeah, that wouldn't work.
You won't get very far. You need those quantum bits, those qubits, to hold their state long enough to actually be useful.
So protons are stable. We can manipulate their spin. It's starting to sound like they really are the perfect candidates for quantum computers.
It really does seem that way.
But it goes even further, right? Schneeberт even talks about using proton spin for quantum communication.
Oh, yeah, that too. This is where entanglement comes in.
Entangled.
That mind-boggling phenomenon.
Right.
Imagine 2 protons entangled. You change the spin of one, the other one instantly changes its spin too, no matter how far apart they are.
Wait, so like instant communication.
Like a telepathic link.
That sounds like science fiction.
It does, but it's real science.
Yeah.
And protons, with their stability and how easily we can manipulate them, they could be the key.
Wow. So we've talked about protons and quantum computers and communication. But Schneeberт also talks about some other uses too.
He does.
Like, let's step out of the digital world for a second and look at how protons are being used in medicine. Have you ever heard of proton tomography?
I have, yeah.
Let me in.
So it's basically a medical imaging technique that uses proton beams instead of X-rays.
Okay.
Like a super high-tech X-ray machine.
But better.
It has some serious advantages, yeah.
Like what?
Well, it's much better at differentiating between tissues.
Okay.
Because protons interact with matter differently than X-rays. We get clearer images, so it's easier to tell the difference between healthy tissue and, say, a tumor.
Wow. So clearer images means more accurate diagnoses, right?
Right.
And probably better treatment outcomes.
Exactly.
But what about radiation exposure? That's always a concern with medical imaging.
That's another area where proton tomography is great.
How so?
Protons have this thing called the Bragg peak.
Okay.
Where they deposit most of their energy at a specific point. So the surrounding healthy tissue gets much less radiation compared to X-rays.
So clearer images and less risk to the patient.
Exactly. It's a win-win.
But wait, there's more. Right. There's also proton therapy.
You got it. And that brag peak is not just for imaging. It's also the basis for proton therapy, a cancer treatment that targets tumor cells super precisely while leaving the surrounding healthy tissue alone.
Like a microscopic surgeon.
Pretty much.
It's amazing that these tiny particles we take for granted are already doing so much in medicine.
I know, right?
And from what we've learned, it seems like their potential in quantum tech is just as big.
Oh, for sure.
Well, I don't know about you, but I'm pretty excited about all this proton stuff.
Me too.
But let's take a moment to let all this sink in before we move on.
Sounds good.
We'll be back soon to continue our exploration of the fascinating world of protons.
Welcome back. We're in the middle of this incredible proton journey, and before the break, we were talking about
all the amazing things protons can do.
Yeah, how they can revolutionize medicine and who knows what else, but there are always challenges with any new technology, right?
Oh, for sure. I mean, working at the quantum level, it's like
what?
It's like trying to build a house of cards in a hurricane.
I like that.
It can't be easy. So what are some of the hurdles we have to overcome with this proton-based quantum tech?
Well, one of the biggest challenges is control.
Control.
Yeah, Schneepat really emphasizes how sensitive protons are to their surroundings.
I can imagine.
Any little disturbance can mess up those delicate quantum states.
It's like trying to whisper a secret in a really loud room.
Exactly.
Wow.
It's super hard to get the message across.
So maintaining that stability, the coherence, is key.
That's the million-dollar question right there.
But how do we do that? How do we create those quiet spaces for these particles to do their thing?
Researchers are working on it from all angles.
Like?
Well, one way is to develop new materials and techniques to isolate and trap protons.
So like building those soundproof rooms you mentioned.
Yeah, exactly. Like creating a perfectly still pond, no ripples.
Oh, I like that.
It's all about creating that perfect, undisturbed environment.
Okay, so that's isolation.
Yeah.
But what about controlling them once they're isolated?
Right, so control systems are also super important. Scientists are developing incredibly precise tools using things like lasers and magnetic fields to manipulate proton spin with pinpoint accuracy.
So they can actually control it.
Yeah, it's like a conductor leading an orchestra of protons.
Guiding them through a complex symphony of quantum operations.
You got it.
It sounds like a very delicate dance between isolating them and then controlling them precisely.
It really is.
It must take a lot of smart people working together.
Definitely. Schneepat talks a lot about the importance of collaboration between different fields.
Oh, okay.
Like physicists, chemists, engineers, computer scientists, everyone working together.
That's amazing. Everyone united by this goal of pushing the boundaries.
Yeah, it's really inspiring.
So, as we look toward the future of proton-based quantum tech, what are some of the most exciting possibilities?
Well, one thing that's super interesting is combining protons with other particles.
Other particles?
Like electrons and photons. Schneepat suggests that this could open up a whole new level of possibilities.
Wait, so combining different quantum particles?
Yeah.
How does that work? Do they all play nice together?
Well, it's about finding their strengths and making them work together.
Okay.
Like, photons are great for transmitting information over long distances.
Right.
But protons offer that stability we were talking about.
Right.
So by combining them, we could create hybrid quantum systems that are even better than the individual parts.
It's like a quantum superhero team.
Exactly.
Each member bringing their own superpower.
I like that.
So what would these hybrid systems look like in the real world?
Well, imagine a quantum computer where protons store information in their spin states.
Okay.
And photons carry information between different parts of the system.
So it's like a quantum brain with a super fast optical network.
Exactly.
That's pretty amazing. But what about uses beyond computers?
Oh, there are plenty. Quantum simulation is a big one.
What's that?
Imagine entangling protons with electrons in carefully designed systems, and we could simulate complex molecular interactions with crazy accuracy.
Wow.
Think about what that could mean for drug discovery or material science.
It'd be revolutionary.
Exactly.
It's like having a virtual quantum chemistry lab.
It really is.
So is there anywhere this proton partnering wouldn't work?
It's definitely a versatile approach.
Right.
Well, quantum communication, for example.
Yeah.
Imagine entangled proton-photon pairs creating ultra-secure communication channels.
Wow.
Like, imagine online banking or government secrets that are impossible to hack.
Oh, that'd be incredible.
It would.
Okay, I'm hooked. So much potential, so many possibilities. It's like we're on the edge of a technological revolution, all thanks to these tiny particles.
It really does feel that way.
But with great power comes great responsibility, right?
You're absolutely right.
So as we get deeper into these proton-based quantum technologies, we need to think about the bigger picture.
Yeah.
What does it mean for society? What ethical questions do we need to ask?
That's a great point. It's something we can't ignore.
Like, what kind of questions are we talking about?
Well, one thing is access and equity.
Yeah.
Who benefits from these technologies and who gets left behind?
Right.
Will it make existing inequalities worse, or can we make sure everyone benefits?
Those are important questions.
They are. We need to be proactive, not reactive.
What about misuse? Could these technologies be used for bad things?
That's always a risk with any powerful technology.
Ew.
Like, imagine quantum computers being used to break encryption codes.
Oh, no.
Or quantum sensors for invasive surveillance.
We need to be prepared for that.
Yeah, we need to anticipate these things and protect ourselves.
So it sounds like we need some serious ethical guidelines and regulations.
Exactly. We need a global conversation.
Why?
Scientists, policymakers, the public, everyone. We need to make sure these technologies serve humanity.
And not the other way around.
Right.
This deep dive into the world of protons has been amazing. We've gone from these simple particles to uncovering their potential to change medicine, communication, even society itself.
It's incredible, isn't it?
But it's clear that we're just at the beginning of this journey.
Oh, absolutely. The possibilities are huge, the challenges are real, and the ethical considerations are profound.
But one thing's for sure. The future of protons in quantum technology is bright.
Yeah.
And we need to be careful and responsible as we move forward.
For sure.
So, we're going to take a short break to collect our thoughts and get ready for the final part of our proton adventure.
All right, sounds good.
Welcome back for the final part of our proton adventure.
Yeah, it's been quite a journey.
We've talked about their crazy inner workings and how they can change everything.
Right, from medicine to communication and more.
And all the ethical questions that come with it.
Like we said, we're at the beginning of something really big.
Yeah, Schnephat's work shows that.
It really does.
So as we wrap things up,
yeah,
it's important to take a step back and look at the big picture, you know?
I agree. What we've been discussing, it's not just small improvements.
Right.
It's like
huge changes.
Yeah, huge changes across a ton of fields.
So we're talking like paradigm shifts.
Exactly. Think about it.
Okay.
A world where quantum computers can solve problems that are impossible today.
That'd be amazing.
Unbreakable communication with quantum networks.
Super secure.
Diagnosing and treating diseases in ways we can't even imagine right now.
All thanks to quantum technology.
It's amazing.
It sounds like science fiction, but it's becoming more and more real.
It really is.
And these protons,
yeah,
the ones we thought were so simple,
I know,
they're turning out to be these powerful tools in this new quantum age.
They are, and Schnephat even hints at even crazier applications in the future.
Like what?
Well, imagine
Okay.
proton-based quantum sensors
Okay.
that can detect tiny changes in gravity.
Gravity?
Yeah, which could help us understand the universe in whole new ways.
Wow. So from these tiny particles to the biggest mysteries of the universe,
It's a mind blow.
protons seem to be the key to unlocking a whole new level of knowledge.
And we can't forget about energy.
Right.
Schnephat talks about this idea of proton-hydrogen technology, which could change how we store and use energy.
Like clean, sustainable energy.
Exactly.
Powered by these little particles.
Yeah.
It's incredible to think that something so small could change so much.
That's amazing.
But it all comes back to what we talked about at the beginning.
What's that?
Protons are way more than just basic building blocks.
They're like little universes themselves.
With incredible potential.
Exactly. And Schnephat makes it clear
What does he say?
that we're just scratching the surface.
So what's the biggest takeaway for our listeners? What should they be thinking about now that they know all this about protons?
Well, I think the main takeaway is that the world is full of surprises.
Even at the smallest levels.
Yeah, we tend to think of science in separate boxes, you know?
Like physics, chemistry, biology.
Right, but at the quantum level, it all blends together.
It's all connected.
Exactly, and this is just a glimpse of what's really out there.
It's pretty awe-inspiring.
It really is, and we've got so much more to learn, so many more mysteries to uncover.
And who knows what amazing discoveries are waiting for us.
Right?
as we keep exploring this quantum world guided by these tiny, mighty protons.
It's an exciting time.
A big thank you to Yurigo Schneepat for his incredible work on protons and quantum technology.
It's been a pleasure exploring this with you.
And to our listeners.
Yeah.
Keep your minds open to the wonders of the quantum world.
There's a whole universe out there waiting to be discovered.
Until next time, keep diving deep.